Function definition. So our objective for this video, determine whether a relation is a function. Now in mathematics, we're going to do a lot of focusing on functions. So it's important to understand what a function is. Well, we know what a relation is. Okay, and these should be dots here. Let's make those dots. Okay, a relation is any set of ordered pairs. And we know that the domain is the first component and the range is the second component of each of those ordered pairs. And we noted in a prior video that, you could have names or you could have nouns, if you will, as a first component or a second component. But we're going to be dealing with functions, and functions deal with numbers. So while a relation may have non-numerical components, a function has numerical components. Okay, so what is a function? A function, it's a relation. It's a particular type of relation in which each component of the domain, also called each input value, also each x value. We're talking about an ordered pair, and so we can speak to that as an x and a y for graphing purposes. So each component of the domain, each input or each x value, corresponds to exactly one component of the range. In other words, for range, the output or the y values. Okay, what happens is it relates an input to an output by a rule. Okay, so for example, if the rule is +2 and I input the number 1, you apply the rule and add 2 to get 3, and I'll output the number 3. So the pair 1, 3 would apply. And again, as I mentioned, we're going to deal with numbers only for functions. Let's take a look at a couple of examples, and I'll give you kind of a visual aid for these. Okay, just a second here. Okay, determine whether the relation below is a function. Recall a relation is simply a set of ordered pairs. Well, this is a set of 4 ordered pairs. It's a relation. Okay, is it a function? Well, I'm going to do it visually by drawing a circle, and I'll say that the numbers inside of this circle are my domain. Well, the domain is the first component, so 1, 2, 3, 4. 1, 2, 3, 4. Those are the entries in my domain. And my range. Okay, I'll draw another circle. Not a particularly pretty circle, but that's not the idea. And my range is 6, 6, 8, 9. Remember, we don't have to write 6 twice. 6, 8, 9. There are 3 numbers in the range. And let's connect them. 1 connects to 6. You input 1, you output a 6. That's fine. You input 2, you output a 6. You input 3, you output an 8. And finally, number 4 in the domain, you input 4 and you output a 9. Okay, is this relation a function? Okay, does each component of the domain correspond to one component of the range? And the answer is yes. The 1 corresponds to 6, the 2 corresponds to 6, the 3 corresponds to 8, and the 4 corresponds to 9. None of these correspond to more than 1. It doesn't matter that both 1 and 2 correspond to 6. 1 and 2 only correspond to exactly one component, and that's the definition of a function. So let's note that. Yes, this relation, if I could spell relation, is a function. Okay. Each input value, each x value. Okay, we can also, remember we talked about this is the inputs. These are also my x values. Okay, each input value, each x value maps. In my picture, we're mapping maps to only one output value or y value. Okay, and again, our range is also called our output values. And when we go to graph them, there'll be our y values. Okay? So this relation is a function because each one of our input values, each member of our domain, each of our x values only maps to one output value, y value, or one member of the range. Let's take a look at a second example in which we simply flip-flop our numbers in our pair. Okay, so is this relation a function? Example 2, 6, 1, 6, 2, 8, 3, 9, 4. Okay, I'm again going to do a visual. Okay, I'll go ahead and draw my circles and my rather sloppy circles. This is my domain. This is my range. And my domain this time, I have a 6, an 8, and a 9. I don't need to write 6 twice. So members, there are three distinct members of the domain, 6, 8, and 9. And there are 4 members of the range, 1, 2, 3, 4. And now let's map. This 6 maps to 1. This 6 maps to 2. This 8 maps to 3. And this 9 maps to 4. Okay, now, is this a function? Does each member of the domain map to only one number, exactly one component of the range? And the answer is no. This 6 maps to both 1 and 2. And that means it's not a function. Each of these can only map to 1. The 6 maps to 2, not a function. So no. This relation is not a function. Okay, well, that's kind of sloppy, isn't it? Sorry about that. Okay, the input value. Now, remind ourselves, these are the input values. These are also the x values. These are the output values. These are also the y values when we go to use equations and graphing. Okay, the input value or the x value, input value 6 maps to 2 output values. Also called y values. And those 2 output values are 1 and 2. So therefore it is not a function. Very important to know this definition because we're going to make use of it a lot in many of our future videos.